Hey there, this is Mr. Wolf. Today we'll be doing benchmark 21. I can find the measure of each or all of the interior and exterior angles of a polygon. Before we get started, a couple reminders. There will be a quiz at the end of this video lecture. The link is on my website, and it should also be down below in the YouTube comments, so make sure you complete the quiz to verify that you did watch it. Remember, you've always got the option to pause or rewind this video if you need to write down something if I'm going too fast. And you are expected to take notes over this video as well, so make sure you've got pen and paper ready and you're jotting everything down. If you have any questions, you can post them on the YouTube page, you can text me, you can email me. I'm always available to help, so please take advantage. Okay, so let's start at the beginning. First, a couple review concepts. Interior versus exterior should be an old concept that's just inside and outside. So if we're referring to interior angles, those are going to be inside the shape. If we're referring to exterior angles, those are going to be outside the shape. What is a polygon? Well, the dictionary definition looks like this. A plane figure with at least 3 straight sides and angles, and typically 5 or more. The easy way to remember is that poly means many, and a gon is a shape, so a many-sided shape. Sometimes you'll hear the term regular polygon. What is a regular polygon? Well, it's a polygon with all sides and all angles that are equal. These are all regular polygons. All the sides are equal, all the angles are equal. A shape like this, that would not be regular. The sides and angles are different. So we'll be dealing with regular polygons just like these here. Otherwise, the rules change. So anytime you see the word regular in math, it means all sides are equal. You also need to differentiate between concave and convex. Okay, a shape that's concave has a side that caves in. Okay, just like this. That is a concave shape. But for our purposes, most shapes we'll deal with are convex. All the angles go outward, nothing caves in. You also need to be familiar with all the shape names. Now, a 3-sided figure is obviously a triangle. 4-sided figures are quadrilaterals. Those include squares, rectangles, rhombuses, so forth. And you might know some of these as well, but I would pause the video at this point so you could write all these down. You'll be expected to know, for example, what a nonagon is. You need to know that's a 9-sided shape. If the test says that you have a nonagon, it may not say it's 9 sides, so you need to know that that's what that means. So pause here and write these down. Okay, so how can we find the sum of the interior angles of the polygon? All right, this is kind of what the benchmark's all about. So we'll start with something familiar here. First, let's start with the triangle. You'll remember from your triangle benchmarks that every triangle adds up. The interior angles always add up to 180 degrees. Okay, there's no disputing that, and we all agree that every triangle adds up to 180. So this makes our job much easier. Our next shape is a square, but we can actually connect these two vertices. And what do we create? Well, we just created two, two triangles. And we know that each triangle is 180 degrees. So 180 times 2, that's going to equal 360. And this applies to other shapes as well. We can take our pentagon here, and I can draw a triangle here, and I can draw a triangle here. And I can't draw any more because this would just connect to this, and this would connect to this. And we've got 3 triangles. Okay, so I end up with 3 times 180. Alright, and by now you should be seeing a pattern. It's actually going to equal 540. Alright, and we'll do one more here for fun. We can divide this hexagon up into triangles as well. And you guessed it, it's going to be 4 times 180. And that equals, what, 720? Alright, whenever I'm playing basketball, sometimes I like to go in for a dunk. Sometimes I'll do a 360, but if I'm feeling really crazy, I'll do a 720. I'll let you figure out how many times around that is. Alright, so let's look and figure out how we can put this as a formula. Alright, it says the sum of the measures of the interior angles of a convex n-gon, where n is just some number of sides, is n minus 2 times 180. Okay, so you need to write down this formula right here. Okay, n minus 2 is 180, where n is the number of sides. So if we go back, think about it. We had a 4-sided figure, do 4 minus 2, and you get 2. Here we had a 5-sided figure, 5 minus 2 is 3. Here we had a 6-sided figure, 6 minus 2 is 4. So we just take the number of sides, subtract 2, times it by 180, and that's going to give us the sum of the interior angles. Remember, sum means them all added up. Okay? Now, if we want to know just what one of the individual angles is, we just take that sum and divide it by however many sides we have. So, for example, let's jump down here. Our pentagon had 720 degrees inside, so 720 was the sum of the interior angles, and in a hexagon there are 6 sides. Okay. So if we do 720 divided by 6, what do we get? 120. So we know each angle is 120. Alright, so write down on your notes that in order to find an individual interior angle, take the sum and divide it by the number of sides in the shape. Okay, pause the video and write that down. Alright, let's do a couple practices here so you guys can see how that works. Again, this is a hexagon, kind of a flattened one, but you can see how it's divided up into 4 triangles. Alright, so we could have done 6, oops, let's get the pen on here. Could have done 6 minus 2, right, times 180, and that's going to give us 720. Or we can do like we were doing and divide it up into triangles, and you'd have 4 different triangles. 4 times 180. 6 minus 2 is 4. 4 triangles. You should see the pattern. Here we've got an 8-sided figure, so we would do 8 minus 2, which is going to be 6 times 180. Or divide it up into triangles, and guess how many triangles this divides up into? Ah, good guess. It does divide up into 6 triangles. 1, 2, 3, 4, 5, 6. Alright, so either way we get the same thing. Alright, a couple more practices here, but I think you get the point. Let's jump to exterior angles here. So exterior means on the outside. Let's start with something familiar. Okay, we've got our triangle. You'll remember each interior angle of an equilateral triangle should each be 60, right? So that's 60, this is 60, and this angle would be 60, okay? We know that the exterior angle here is supplementary to 60. Since they're on this straight line, you know they're going to add up to 180. So what does this angle right here have to be? It has to be 120, because 180 minus 160 is 120, which makes this one 120, which makes this one 120. So those are the 3 exterior angles. If there's 3 interior angles, then there's 3 exterior angles. You got 120 plus 120 plus 120, and that equals 360. Okay? Down here we've got a square, and you know this is 90, which means the exterior angle is supplementary to 90. 180 minus 90 is 90. So this exterior angle is 90, just like the interior. And this exterior angle will be 90. This one's 90. This one's 90. 90 plus 90 plus 90 is, well, that's weird, it's 360 again. Okay. One more. This is a pentagon, and a pentagon, each individual angle, if you do your formula, you'll find out is 72 degrees. Alright? We subtract 72 from 180, and what do you get? Well, you get 108. Oh, you know what? I just realized I did that backwards. I apologize. interior angles are 108, which makes the exterior 72. And this one would be 72, and the other one, and the other, and the other one. And so you've got 5 angles, and they're 72 degrees each. So the sum of the exterior angles, when you multiply that, is actually 360. And so you've probably figured out by now that the sum of the exterior angle measures, one angle at each vertex of a convex polygon, is 360. It's that simple, guys. All you've got to remember is exterior angles, always 360. Always. If you want to find an individual exterior angle, take your 360 and just divide it by however many sides you got. So if it's a 4-sided figure like a square, divide it by 4, and you see that each individual exterior angle is 90. Pretty simple stuff. Okay, I think that brings us to the end here, so let's do a little summary. Okay, first we discussed interior angles, and we figured out that in order to find the sum of interior angles, we take the number of sides, subtract 2, and then times that by 180. And that gives us the sum of the interior angles. If we just want one interior angle, well, then we just simply divide that by whatever the number of sides is. Okay? So there's your formula for one interior angle. And if you just wanted to find the sum, just remove that in. Okay? Next, we learned that when dealing with exterior angles, it's actually much simpler. Every single time it adds up to 360. And if we want just one, what do? You guessed it. We just divide it by the number of sides. All right. Okay, make sure you take good notes. Make sure you click on the quiz below and complete that to verify that you watched the video. As always, you can visit my website for help. You can visit Khan Academy to get some practice on this topic. And you can always text me at 286-4430, and I'll be happy to help you. Okay, Matt, this is Mr. Wolf, signing off.